Hello, and welcome to the Math 120 Final Exam Review, Linear Functions. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. That's the school that this review is for, Doña Ana Community College. The final exam review can be found at dacc.nmsu.edu/math. And on the right side menu, you can find final reviews. All of these problems I've taken from that review. I've just grouped them according to the type of function they are. So, first problem, this is a no calculator problem, as you can see by the fanciness I've included over here. So, we expect you to not need a calculator for this type of problem. The gross profit P for ExxonMobil Corp. In billions of dollars, T years since 2000, can be represented by the equation P equals 12T plus 13. Part A, we want to give the slope of this equation and write a sentence that explains its meaning in the situation. Now, the slope is 12. The slope, we think of the form y equals mx plus b. The m is the coefficient of our variable in any linear equation, so the slope is 12. But what does it mean? In explaining its meaning in the situation, you want to use the units involved in the situation. The units are billions of dollars per year, right? The gross profit is billions of dollars, and T is the number of years. So what this 12 means is the gross profits were increasing, because it's positive, by $12 billion per year for ExxonMobil Corp. Over this particular time period. Now, what is the p-intercept of this equation? We're used to saying y-intercept, but this equation doesn't have a y, it has a p. It's in the same place as y, so it's the same idea. The p-intercept of this equation will be the number 13. Right? When the time is 0, we get 13. Write a sentence that explains its meaning in the situation. Well, knowing the number is fantastic, it's a great start, but once again, what does that mean? Well, when time is 0, so in the year 2000, the gross profits for ExxonMobil Corporation were $13 billion. Always in terms of the units of the problem. And what did we use at t equals 0? What does that mean? All right, let's try another one. A little less color coordination on this next one. The annual amount A of public expenditure on medical research in billions of dollars in the United States, T years since 2000, can be estimated by the equation A equals 4.02T plus 25.8. We want to give the slope of this equation and write a sentence that explains its meaning in the situation. Well, the slope, right, the coefficient of the variable, 4.02, right, the slope is always associated with the variable. In this situation, what is our A value? Billions of dollars of medical research. What is our input value? T years. So it means that approximately $4.02 billion per year is being spent on medical research in the U.S. for the time period this equation works for. Give the A-intercept of this equation and write a sentence that explains its meaning. The A-intercept is the constant. It's the part that doesn't have the variable, 25.8. In this particular situation, what does it mean? When t is 0, so in the year 2000, right, at 0 years past 2000, when t is 0, the annual amount of public expenditure on medical research is $25.8 billion. So it means that $25.8 billion was spent on medical research in the United States in the year 2000. All right, good job. Number 15, part C, we're going to find the inverse of this linear function, h of x equals negative 3x plus 1. We'll find several different inverses throughout this series of videos. We're going to start with just the linear. Remember, our steps are, first, we replace h of x with y. Much easier to do manipulations on an equation with a single variable rather than function notation. Now, what an inverse does is it switches x and y. All right? What was an input becomes an output. What was an output becomes an input. So our second step, what was a y becomes an x. What was an x becomes a y. Those two steps are what I call cosmetic. It's just a change in the look. We haven't done any real work yet. Even though this switch right here, this is the most important step with an inverse. You're switching the variables. for a generic function like this. Now we want to solve for y. So the first thing I'm going to do is I'm going to subtract 1 from both sides. Once I have x minus 1 equals a negative 3y, I'm going to divide every single thing by the negative 3. So x divided by negative 3 minus 1 divided by negative 3. And when I divide negative 3y by negative 3, I get just y. That's what I wanted, a y by itself. Now this is alright, but we're going to clean it up a little bit. X divided by a negative 3, that's a negative 1/3 x. Right? There's a 1 in front of the x. Bring the numbers out in front, make it our fraction. Minus 1 divided by negative 3, the two negatives make a positive, so positive 1/3 equals y. Step 4, right, rewrite as y equals, switch x and y, solve for y. Step 4, rewrite in function notation. This function has the name h, so its inverse will have the name h inverse of x, and it equals negative 1/3 x plus 1/3. Next problem. In 2001, 408 teenagers underwent gastric bypass surgery. In 2003, 771 teenagers underwent gastric bypass surgery. Part A. Use this information to write a linear model for the number of teenagers having gastric bypass surgery T years since 2000. Now this is important. This little phrase right here, T years since 2000, tells us two very important things. It tells us that our variable needs to be t, our input variable is t, and we're looking at years since 2000. So the year 2001 is 1 year later, right? 1,408 teenagers. In 2003, that's 3 years after 2000, there were 771 teenagers that underwent the surgery. So we can use this information, our two sentences, to write this information in terms of 2 points. As soon as I see this word right here, linear model, I'm thinking slope, y-intercept, y equals mx plus b. I got to find a slope. I need a couple of points. So I have my 2 points, scaled since 2000. To find the slope, we subtract y values, 771 minus 408, and then subtract x values, or t values, in the same order, 3 minus 1. All right, the 771 comes first, the 3 has to come first. When we do our subtraction, 771 minus 408 gives us a numerator of 363, where 3 minus 1 gives us a denominator of 2. 363 divided by 2 is 181.5. Notice there's no calculator logo up here. You will be allowed the use of a calculator for this particular problem. So don't worry about the numbers. You'll be able to do that on a calculator. Next, we find the y-intercept. And I use the formula y minus y1 equals m times t minus t1. Usually it's x minus x1, but I want to emphasize the t variable. So I'm going to pick the easy point. And the easy point for me is just the one with smaller numbers. So y minus 408 equals our slope, 181.5, times t minus 1. Then we'll distribute the 181.5 times t and 181.5 times negative 1 to get this equation. I did nothing on the left-hand side. When I add 408 to both sides, I should do that correctly. It looks like I made a mistake here. That is not 589. I have a negative 181, a positive 408. I should do that in my head, but I'm not going to. With a quick little figuring there, we have a 226.5. Look how easy it is to make mistakes. One little sign, I used a positive 181.5 instead of the negative, messed me up. Oh well, 226.5 should be our equation. Now, according to our model, and this is our model with the correct number, 226.5, we can estimate how many teenagers have gastric bypass surgery in 2006. And I should have known that I was wrong here when my number was so huge. 226.5 plus 6 times 181.5. Yeah, once again, I would need to use a calculator. And it looks like when we multiply 181.5 times 6, right, because 2006 is 6 years later, and I add 226.5, this should be 1,315.5 teenagers underwent gastric bypass surgery in 2006. Now, I know half a teenager didn't undergo bypass surgery in 2006. A much better approximation, we'd either round up, round down. It is on average. This is a model. Models are not exact in every situation, but it gives us a pretty good idea of how many teenagers, underwent gastric bypass surgery for that one. Whoo, pay attention to your details before you start recording things and throwing them out into the internet. According to the Nutritional Sciences Department at Penn State University, a woman's optimal weight is 100 pounds at 5 feet tall and 130 pounds at 5 feet 6 inches. We're going to use this information to write a linear model for the woman's optimal weight in pounds based on the number of inches her height is above 5 feet. Once again, we have a scale factor. Instead of years after 2000, it's the number of inches above 5 feet. Well, 100 pounds at 5 feet. 5 feet is 0 pounds taller than 5 feet. So 0 pounds. 0 inches higher than 5 feet. So 0, 100 pounds. 6 inches later, we have 130 pounds. We can find our slope, 130 minus 100. And then in the denominator, we subtract the x values in the same order. So 6 minus 0. 30 divided by 6 is 5. We know our slope is 5, and look at that. We have a y-intercept right here. Because we're given the y-intercept, we can just write our b value. We don't have to use y minus y1 equals m times x minus x1. So we have our equation y equals 5x plus 100, where x is the number of inches over 5 feet tall, and y is the weight of this particular woman, which you should never talk about. I'm just saying. Anyway, according to your model, what's the optimal weight of your instructor if she's 5 feet 8 inches tall? And I happen to be 5 feet 8 inches tall. Well, that's 8 inches over 5 feet. So I'm going to put an 8 in for x. Y equals 5 times 8 plus 100. So that's 40 plus 100, which is 140 pounds. But I got to tell you, when I weigh 140 pounds, you're going to want to do an intervention because it looks like I'm on some very nasty drugs. Don't believe this, all right? You can be healthy and be heavier. You could be unhealthy and be thinner. You're beautiful just the way you are, people. You're beautiful just the way you are. The equation d of t equals 650t plus 8,400 represents the tuition, d dollars, at a college for the year that is t years since 2000. We're going to find an inverse for this model. Now, we talked about an inverse earlier in h of x. And that was just a generic function. And when we have a generic function, we switch x and y. But d actually means something. D means dollars. T is a number of years. So we're going to rewrite our equation, but take away function form. I'm going to call it d equals, the number of dollars, equals 650t plus 8,400. No, I'm not going to switch my d and t. I can't just randomly decide to change the letters on this. What I do instead is I solve for the other variable. Here d is by itself, so we want to get t by itself. Let's subtract 8,400 from both sides. So d minus 8,400 equals 650t. Get t by itself, we're going to divide everything by 650. So we'll have d divided by 650 minus 8,400 divided by 650 equals 650t divided by 650. And then we might choose to rewrite this in function notation. The number of years is dependent on the dollars, which equals 1 over 650d minus 168 over 13. I got to tell you, I also accept this answer. T equals d minus 8,400 all over 650. To me, that's an acceptable answer, but you need to check with your instructor to make sure my acceptable and their acceptable are the same thing. This is the better form for overall generic for everybody. And then I reduced 8,400 over 650 to get my fraction. Now, this is our inverse model. So if we know the year, we can find the dollars. If we know the dollars for tuition, we can find the year. Find the year, so we're going to use our inverse, when the tuition was $9,700. So when the dollars was $9,700, we'll evaluate. Everywhere we see a D, we're going to replace it by 9,700. Remember, no calculator icon up here, so we could use a calculator on this. 1 over 650 times 9,700 minus 168 over 13. Put that into a calculator and I get 2. So 2 years later, 2 years after 2002, 2 years after 2000 is the year 2002. The tuition was $9,700. Whew, that was a mouthful. One more problem. The AEM Toy Company has a profit of P of D equals 4.5D minus $300 when D dolls are sold a month. Alright, so the profit is in dollars, D is the number of dolls now. We want to find an inverse. Our first step for an application problem where the variables mean something, it's not just generic X and Y, our first step is to rewrite without function notation. So P equals 4.5D minus 300. We'll add 300 to both sides, and then we'll divide everything by 4.5 so we can get D by itself. All right, here we had P by itself, now we want D by itself. This is our inverse. I did simplify my fractions. 1 divided by 4.5 gives you 0.22222. I put that in fraction form as 2/9. 300 divided by 4.5. Oh, that gives you a number that simplifies to 200 over 3, as it turns out. Divide each of them by 1.5, see what happens. Find the amount of dolls needed to produce a profit of $20,000. So find the number of dolls. My profit is 20,000. I want my input to be 20,000. So if P is 20,000, I evaluate my D equation with a P value of 20,000, 2/9 times 20,000, plus 200 over 3 is 4,511.11111. But seriously, how do you make 0.11 of a doll? We're going to round that to the whole number of dolls. Because if you only make 4,511, you haven't made a profit of 20,000 yet, right? That little bit under. So you have to make the 4,512th doll before you actually hit the 20,000 mark. I know that's a lot. That's linear. Take a break before you go and look at the other ones. Practice these problems several times on your own. Check your answers with mine. Check your answers with the solutions given on the back 2 pages of the review. Thanks for listening.